here's another example. And this one's going to be a little bit different, but as we get going along with this, hopefully this will get a lot simpler for you. So instead of vectors of force, we're going to have vectors of velocity. Vector 1, 48 degrees, 50 meters per second. Vector 2, 147 degrees, 75 meters per second. So we're going to draw the vectors individually. Vector 1 looks like this. And vector 2 looks kind of like this. Vector 1, vector 2, 48 degrees, 50 meters per second, and 147 degrees, 75 meters per second. All right. So now we can infer that they are the resultants of component vectors that go like so. Now we got a little rub here. That's 147 degrees, so what's this angle? Well, that would be 180 degrees here. So 180 minus 147, that should be 33 degrees. All right. Now, we know that we're going to total up A1, A2, to get an A total, O1, O2 to get an O total. We know that we're going to use cosine to figure out A. We're going to use sine to figure out O. But before we do that, there's one other thing you need to pay attention to. Notice the directions here. So A1 is pointing this way, so I'm going to put an arrow right here. A2 is pointing in the other direction, so I'm going to put an arrow like so. O1 is pointing up. O2 is pointing up. Now, the reason I did that is to make things a little bit simpler. That's in a positive direction. That's in a negative direction. Going up is a positive direction. So now I don't have to worry about negative trig functions. That's what I meant earlier on when I said we're going to draw pictures and bypass the issue of negative trig functions. So now we'll walk them through. So to figure adjacents, I use cosine, so I'm going to go cosine 48 times my hypotenuse of 50, and I got 33.457. Here I'll go cosine of 33 times my hypotenuse of 75. I get 62.900. Now I'll use sine for my opposites. Sine 48 times my hypotenuse of 50. 37.157. Sine of 33 times my hypotenuse of 75, 40.848. All right, now I'll tally them up. 33.457 minus 62.900. 0.900. I got negative 29.443. $37.157 plus 40.848, 78.005. All right, now we'll take a look and see what this guy looks like. All right, I'm going to draw my horizontal vector first. 29.443, it's negative, so that means it's going to go in this direction. 29.443. And notice I do not put a negative sign here. And the reason that I don't is because I don't have to. I've already indicated the direction. 78.005. It's positive, so it's going to go like this. Okay, so this will be my resultant. Here's my unknown angle, theta. So, the tangent of that angle, opposite over adjacent, which in this case is 78.005 over 29.443. I got 2.649. I'll use the reciprocal function. And let's see what angle we get here. 69.3. So now I'll figure out the hypotenuse. Hypotenuse is going to equal opposite over the sine of 69.3. .935. $83.428. Okay, we're almost done, but there's one thing that we've left to do. Yes, this angle here is 69.3 degrees. That is true. But what we want is this angle, the actual angle. So that's easy. We take 180 and subtract 69.3. $110.7 degrees. So the resultant here is 83.428 meters per second at an angle of 110.7 degrees. All right, we'll pause here. I have one more example for you.